The National Electrical Code, or NEC, does not provide official answer keys to test questions found in the Illustrated Guide to the National Electrical Code or any other publications. However, you can find unofficial sources that may provide some assistance. Firstly, online forums and communities such as Electrica Forum, Com Inspectopedia, Com and Cosmiths. Com can be valuable resources. These platforms often host discussions about code interpretations and calculations, and you might find answers or explanations related to specific test questions. Keep in mind that the information shared on these forums is not official and should be verified against the NEC itself. Secondly, YouTube channels dedicated to electrical code education can be helpful. Channels such as Mike Holt Enterprises and Pass the Electrical Exam offer video tutorials and explanations of various code sections and calculations. Searching for videos related to specific topics or questions from the Illustrated Guide might yield relevant information. Again, remember to cross-reference the information with the official NEC. Thirdly, books and study guides, such as the National Electrical Code 2023 Study Companion by Mike Holt and the Exam Prep National Electrical Code 2023 by Charles R. Miller, can provide comprehensive coverage of the code and practice questions. These resources often include detailed explanations and calculations, which can be helpful in understanding the underlying principles behind the code requirements. While these official sources may provide answers to some test questions, it's crucial to remember that they are not substitutes for the official NEC. Always consult the latest edition of the NEC for the most accurate and up-to-date information. When studying for the NEC exam, it's recommended to use a variety of sources to ensure a comprehensive understanding of the material. This includes the NEC itself, study guides, online resources, and practice exams. Understanding the structure of the NEC is crucial. The NEC is organized into chapters, articles, and sections. Each section contains specific requirements for electrical installations. Familiarizing yourself with this structure will make it easier to locate relevant information when you encounter a question. Understanding the definitions in Article 100 is very important. The NEC includes a comprehensive set of definitions in Article 100. Understanding these definitions is essential for interpreting the code correctly. Pay close attention to the definitions of terms that are frequently used in the NEC, such as ampacity, equipment grounding conductor, and ground fault circuit interrupter. Performing calculations accurately is key. Many NEC test questions require you to perform calculations to determine things like conductor size, overcurrent protection, and voltage drop. Make sure you are comfortable with the formulas and calculations methods used in the NEC. Some important calculations include Ohm's law, power formulas, and voltage drop calculations. Knowing where to find information in the NEC is critical to passing any exam. The NEC contains numerous tables and examples that provide valuable information for electrical installations. Familiarize yourself with the most commonly used tables, such as those for conductor ampacity, conduit fill, and overcurrent protection. For example, Table 310.16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, based on their insulation type and temperature rating. NEC Article 210 covers branch circuits. Branch circuits are the circuits that extend from the final overcurrent device to the outlets. Understanding the requirements for branch circuits is essential for ensuring safe and reliable electrical installations. Some key requirements include the number and type of outlets allowed on a branch circuit, the minimum size of conductors, and the type of overcurrent protection required. NEC Article 250 addresses grounding and bonding. Grounding and bonding are critical for protecting people and equipment from electrical shock and fire hazards. Understanding the requirements for grounding and bonding is essential for ensuring electrical safety. Some key requirements include the size and type of grounding conductors, the methods for grounding equipment, and the requirements for bonding metal enclosures. NEC Article 300 covers wiring methods. Wiring methods refer to the ways in which conductors are installed and protected. Understanding the different wiring methods allowed by the NEC is important for selecting the appropriate wiring method for a particular application. Some common wiring methods include rigid metal conduit, electrical metallic tubing, and non-metallic sheath cable. NEC Article 430 covers motors and motor circuits. Motors are used in a wide variety of applications, and understanding the requirements for motor circuits is important for ensuring safe and reliable operation. Some key requirements include the size of conductors, the type of overcurrent protection, and the requirements for motor control centers. NEC Article 440 addresses air conditioning and refrigeration equipment. Air conditioning and refrigeration equipment have unique electrical requirements, and understanding these requirements is important for ensuring safe and efficient operation. Some key requirements include the size of conductors, the type of overcurrent protection, and the requirements for disconnecting means. Voltage drop calculations are essential for determining the proper conductor size. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction and can also create a fire hazard. The NEC recommends that voltage drop should not exceed 3% for power, heating, and lighting circuits, or 5% for feeders. Conductor ampacity is the maximum current that a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables that list the ampacities of different types of conductors based on their size, insulation type, and temperature rating. It is important to select conductors with an ampacity that is sufficient to carry the expected load. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The NEC specifies the maximum overcurrent protection allowed for different types of conductors and equipment. It is important to select overcurrent protection devices that are properly sized to protect the circuit. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. GFCIs detect ground faults, which occur when current flows through an unintended path to ground. When a ground fault is detected, the GFCI quickly interrupts the circuit, preventing electrical shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or RFCIs, are designed to protect against fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating heat that can ignite nearby materials. RFCIs detect arcing faults and interrupt the circuit, preventing fires. RFCIs are required in many locations, such as bedrooms and living rooms. The National Electrical Manufacturers Association, or NEMA, is an organization that develops standards for electrical equipment. NEMA standards cover a wide range of products, including enclosures, wiring devices, and motor control centers. Understanding NEMA standards is important for selecting the appropriate equipment for a particular application. Underwriters Laboratories, or UL, is an independent testing organization that certifies electrical products. UL-listed products have been tested and found to meet UL safety standards. Using UL-listed products is important for ensuring electrical safety. The authority having jurisdiction, or OJ, is the local electrical inspector or other official who is responsible for enforcing the NEC. The AHJ has the authority to approve or disapprove electrical installations. It is important to work with the AHJ to ensure that your electrical installations comply with the NEC. The NEC is constantly updated to reflect changes in technology and industry best practices. It is important to stay up to date on the latest edition of the NEC to ensure that your electrical installations are safe and compliant. Continuing education courses are a good way to stay up to date on the NEC. Many organizations offer continuing education courses on the NEC, including trade associations, community colleges, and online training providers. Reviewing the NEC regularly is important. Even if you have taken continuing education courses, it is still important to review the NEC regularly to refresh your knowledge and stay up to date on any changes. Using the NEC Index can help you find information quickly. The NEC Index is a comprehensive listing of all the topics covered in the code. Using the index can help you quickly locate the information you need. Participating in electrical industry events can help you network and learn. Electrical industry events, such as trade shows and conferences, provide opportunities to network with other professionals and learn about the latest technologies and trends. Seeking mentorship from experienced electricians can provide valuable guidance. An experienced electrician can provide valuable guidance and insights into the NEC and electrical installations. Consider seeking mentorship from an electrician who has a strong understanding of the NEC. Joining electrical trade associations can offer access to resources and training. Electrical trade associations offer a variety of resources and training opportunities for electricians, including access to the latest codes and standards, continuing education courses, and networking events. Consulting with a qualified electrical engineer can ensure compliance with complex installations. For complex electrical installations, it is always a good idea to consult with a qualified electrical engineer to ensure that the installation complies with the NEC and other applicable codes and standards. Following manufacturer's instructions is crucial for safe equipment operation. Always follow the manufacturer's instructions when installing and operating electrical equipment. Failure to follow the manufacturer's instructions can lead to equipment damage, electrical shock, or fire. Inspecting electrical installations regularly can identify potential hazards. Regular inspection of electrical installations can help identify potential hazards such as loose connections, damaged wiring, and overloaded circuits. Addressing these hazards promptly can prevent electrical shock and fire. Keeping accurate records of electrical work is important for future reference. Maintaining accurate records of electrical work, including wiring diagrams, equipment specifications, and inspection reports, is important for future reference. These records can be helpful for troubleshooting problems and for planning future modifications. Always energize circuits before working on them to prevent electrical shock. Before working on any electrical circuit, always de-energize the circuit at the source. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Verify that the circuit is de-energized using a voltage tester before touching any wires or equipment. Using appropriate personal protective equipment, or PPE, is essential for electrical safety. When working on electrical circuits, always wear appropriate PPE, such as safety glasses, gloves, and insulated tools. PPE can help protect you from electrical shock and other hazards. Reporting electrical hazards promptly can prevent accidents. If you see an electrical hazard, such as exposed wiring or a damaged outlet, report it promptly to the appropriate authorities. Reporting electrical hazards can help prevent accidents and injuries. Obeying lockout/tagout procedures is crucial when working on equipment. Lockout/tagout procedures are designed to prevent equipment from being accidentally energized while it is being worked on. Following lockout/tagout procedures can help prevent serious injuries. Not exceeding the rated capacity of electrical systems is important. Electrical systems are designed to operate within a certain rated capacity. Exceeding the rated capacity of an electrical system can overload the system and create a fire hazard. Understanding electrical symbols and diagrams aids in troubleshooting. Familiarizing yourself with electrical symbols and diagrams can help you understand how electrical circuits are wired and how to troubleshoot problems. Using a systematic approach to troubleshooting electrical problems can save time. When troubleshooting electrical problems, it is important to use a systematic approach. This involves identifying the problem, gathering information, testing components, and making repairs. Performing preventive maintenance on electrical equipment extends its lifespan. Preventive maintenance, such as cleaning, lubricating, and tightening connections, can help extend the lifespan of electrical equipment and prevent problems. Proper disposal of electrical waste protects the environment. Electrical waste, such as batteries and fluorescent lamps, can contain hazardous materials. It is important to dispose of electrical waste properly to protect the environment. Adhering to all applicable codes and regulations ensures safety and compliance. In addition to the NEC, there may be other applicable codes and regulations that govern electrical installations. It is important to adhere to all applicable codes and regulations to ensure safety and compliance. Remember that while these resources can be helpful, they should not be used as a substitute for understanding the NEC itself. Take the time to study the code carefully and to understand the underlying principles behind the requirements. By doing so, you will be well prepared to answer test questions and to ensure safe and compliant electrical installations.